Hello, advanced algebra students. I think we're ready to go with our new material, which is going to be from 3.3, and we are going to start talking about trig ratios in the plane. So if you remember, we left off by talking about trig ratios, how we had a right triangle, and we could find the different sine, cosine, and tangents by knowing which sides to compare. Well, now we're going to extend that. We're going to look at how we can do it for different angles that aren't a part of a right triangle. In other words, they're bigger than 90 degrees. They can be less than 90 degrees too, but we're going to see how we do that. So right now we're only going to stick with and consider our special right triangles. So we're going to start with a 45, 45, 90, and we're going to build what we call a reference triangle, which is going to be the simplest possible 45, 45, 90 right triangle, the simplest possible sides I could have. Well, when I go and do this, the simplest possible sides, if you remember, when you have a leg, you have to multiply it by radical 2 to get the hypotenuse. So the simplest possible leg you could have, if you want to pick your simplest number for a length of a leg, the simplest number is going to be 1. So if your leg is 1, then your hypotenuse must be radical 2. So this is what our reference triangle looks like for 45, 45, 90. We pick the simplest possible legs possible, which are 1, and then it makes our hypotenuse radical 2. There's no simpler one than we can get than that one. I could pick different values for legs, but I'm still going to have to multiply by radical 2. It's not going to be as simple in the end. So that's our reference triangle right there. Now it becomes pretty easy to figure out what the sine, the cosine, and the tangent are for a 45-degree angle, the angle inside of our triangle here. So I want to first take a look at the sine of 45. Notice I could pick either 45-degree angle, doesn't matter. I know sine is opposite, or 1 over radical 2. So I've got that 1 over radical 2. And then I want to rationalize that denominator. If I have a radical 2 in the denominator, I always want to rationalize it, so I'll multiply top and bottom by radical 2 and end up with radical 2 over 2. For the cosine of 45 degrees, notice it's going to be exactly the same thing. So if I have 45, the adjacent is still 1, hypotenuse is radical 2, same thing. So sine and the cosine of 45 are the same. Tangent is not the same. Tangent, if I want to look at this 45 here, I have opposite over adjacent. So I've got 1 over 1, which is just 1. So you don't have to memorize these things here if you know your reference triangle. If you know your reference triangle, then it's easy to figure these things out. If you want to memorize these things, you can, and then you really don't need the reference triangle. But otherwise, know the reference triangle, and then you can quickly get the sine, cosine, tangent. All right, the other type of triangle that we know exact values for that comes up, our other special one, is a 30, 60, 90. So let's build a reference triangle for a 30, 60, 90. If you remember, in a 30, 60, 90, everything was built off of the short leg. The hypotenuse was 2 times the short leg, and the long leg was radical 3 times the short leg. So the simplest possible short leg we could have is one that's equal to 1. So we're going to build one off of a 30, 60, 90 right triangle where the short leg is 1. That makes the hypotenuse 2 times that, so that's 2. And it makes the long leg 1 times radical 3, or just radical 3. Now I can go ahead and figure out the trig ratios for the angles in a 30, 60, 90 right triangle, namely 30 and 60. So to start with here, we'll start with, and we've got the sine of 30. So looking for the sine of 30, I'll take if this is my 30-degree angle, the opposite side is 1. That's opposite of 30. Hypotenuse is 2, so I have 1/2. For the cosine of 30, the adjacent side is radical 3. The hypotenuse is still 2. So for the cosine of 30, I've got radical 3 over 2. Finally, for the tangent of 30, I have 1 opposite over adjacent radical 3. And this is one where we don't bother to rationalize that denominator. If we have a radical 2 in the denominator, One of the things we find out is those 2's are very common in the denominator. See up here how we have all these 2's. If we have a radical 2 in the denominator, we're going to rationalize it to get it over 2. Like these are over 2 here. But we're not going to worry about it if it's a radical 3. We'll just leave that as 1 over radical 3. All right, now let's look at the 60-degree angle. So the sine of 60, so I have the opposite is radical 3 over the hypotenuse is 2. So it's radical 3 over 2. The cosine of 60, the adjacent is 1, and the hypotenuse is a half. Sorry, hypotenuse is 2, so the cosine of 60 is 1/2. And finally, for the tangent of 60, the tangent, we go opposite radical 3 over 1. Well, radical 3 over 1 is just radical 3. So that's how we would find the sine, the cosine, and the tangent with our reference triangle there for a 30, 60, 90. Now let's go ahead and now we're going to put it into the plane. And when we say the plane, we mean the coordinate plane here. So remember, we already talked about this back in 13.1, the way you can measure angles in the coordinate plane. The way you can talk about angles, you start with the positive x-axis and then go counterclockwise if it's positive and clockwise if it's negative to get our angle. So let's look at some of these. So A, let's go sine of 60. Now granted, I could just look above and know this, but let's see how we do this when it's in the plane. So if I think of 60 degrees, the good news is the assignment you have today, they're actually going to already give you a picture. But eventually you'll get to a point where they won't give you a picture, and so you need to sketch 60 degrees in the coordinate plane. So that's what I've done here. Here's 60 degrees. Starting here, coming around here, 60 degrees. And then I turn it into a right triangle. Always turn it into a right triangle by drawing the segment that joins to the x-axis. That's very key. So once I turn it into a right triangle, notice what I have. This becomes, since this is a 60-degree angle, this is the short side, it's 1. The long leg is radical 3. Hypotenuse is 2. So the sine of 60, here's my 60-degree angle, I look at the opposite side, radical 3, or the hypotenuse 2, and I get radical 3 over 2. Let's look at another one. Let's look at the cosine of negative 120 degrees. So now we've got an angle that's clearly not a part of a right triangle, negative 120, but we can still talk about its cosine. So let's go ahead and let's take a look at what we see here. So the first thing we have to do is sketch 120 degrees. So notice here's my coordinate plane. Here's the sketch of 120. We come down to here, that's negative 90, because we're going in the clockwise manner, because this is a negative angle. And then I have to go 30 more. So if this is 30, this is 60, which then when I join this to the x-axis, I get a 30, 60, 90 right triangle. And if this is 60, this is the short side. Notice though, it's in the coordinate plane. So the x value for this is not 1, but negative 1. And this is down, so the y value here is negative radical 3. So now when I want the cosine, I'm looking at this angle here. I'm looking inside my right triangle there. The cosine, the opposite, the adjacent is going to be negative 1. By the way, the adjacent is always going to be in the x value, and the opposite is always going to be the y value. So the adjacent here is negative 1, and the hypotenuse is 2. So I've got negative 1 over 2, or negative 1/2. The hypotenuse is also always positive. It is the distance away from the origin. So the x and the y are determined positive and negative by what quadrant they're in, but the hypotenuse is always positive. Let's look at another one. Now let's calculate the sine of 225 degrees. First thing to do is sketch it. So if we sketch that, here's our sketch. We start here. We're positive, so we start going counterclockwise. We come around 90, 180, and then I must go 45 more past 180. So that makes this a 45, 45, 90 right triangle. Notice I join this here to the x-axis, and I get this one here. So I get, since it's 45, 45, 90, it's 1, 1 radical 2, but I know it's negative 1 because of where it is in the coordinate plane. And the radical 2 is always positive. Now I can pick out the sign. Sign is the opposite side, -1. Notice it's always the y over my hypotenuse radical 2. So it is -1 over radical 2. We do want to rationalize that denominator and get negative radical 2 over 2. All right, for D, let's look at the tangent of -45. If I'm going too fast, just pause the video and finish your sketches, and then we can finish. So for D, here's a sketch of -45 degrees going in the negative direction. Notice that makes this a 45, 45, 90. So this is 1, positive direction for X, -1, negative direction for Y. So tangent is going to be opposite the Y over the adjacent, the X, and I get -1 over 1, which is just -1. Two more. Let's look at the cosine of -315 degrees. So first we have to sketch -315 degrees. So here's -315. Start here and go in the negative direction. So we're going clockwise. So we go 90, 180, 270, and then I have to go another 45 degrees, making this 45 here if this is 45 there. Notice now this is 1, 1 radical 2. Cosine is this over this, the x over the hypotenuse, so that's 1 over radical 2, but about this time I already should know when I see 1 over radical 2, I know that's radical 2 over 2. That's what I get when I rationalize that denominator. Okay, last one, tangent of 150. Let's draw 150, so it's positive, so it's going here in the counterclockwise direction. So I come around here, 150 is just 30 degrees short of 180. So I know then that this is a 30, 60, 90. This has to be the short leg, because it's always opposite the 30-degree angle. This has to be the long leg. But notice this y is above, so it's positive. This x is negative, it's to the left. And there's my 2 there. So the tangent is the opposite, the 1 over the negative root 3, which we'll just write as -1 over root 3. Okay, that's what you'll be doing. There's a worksheet with a lot of these problems. Like I said, most all of them are already sketched for you, so you can just go ahead and make your triangle out of it and get your answer that way. So hope it goes well, and shoot me a message through Classroom if you have a question. Here's your homework, though. It's that worksheet. Make sure you give me the exact answers. Don't give me the decimal answers. I know you can punch it in your calculator, get a decimal. I'm not interested in those. We want the exact answers. So that's 15 through 34 all. Okay. Hope it goes well, and we'll see you tomorrow.